Hi, I'm Willa.
I'm Ellie.
I'm Samantha.
And I'm Kira.
We are Learning Team 6. Our EdgeRock model was called the Survivor, and hence the name, we survived all 3 drops. We had an amazing design, and even though we didn't win and came in 4th due to its weight, we are very proud of how well we worked together and how efficient our design was. After talking about our fantastic egg drop design, you probably want to know more about it. Luckily for you, that's exactly why we're here.
In order to increase air resistance or fluid friction, we put a large parachute made out of a trash bag to catch air during the device's fall. This increased the surface area, which then increased the fluid friction, which lengthened the amount of time it took to hit the ground. This made a smoother landing because less force could be exerted on the egg.
Second, we had a very open base so the design itself could catch air. Similarly to the parachute, it lengthened the time it took before it hit the ground.
We also took advantage of the long red strings attached to the garbage bag parachute. We stretched out the strings so that they were very long and all the same length. If we were to have very short strings attached to the model, then it would not have caught air quite as quickly as it did.
Lastly, we attached a long white string from the center of the parachute to the top of the compartment holding the egg. This helped to keep our model upright so it could catch more air, keep the parachute from getting tangled, stay as big as possible, and ensuring that it would land properly. Our fall time to the top of the stairs on the science balcony increased by a whole 1.5 seconds because our parachute was stabilized and able to catch more air. Our design helped to reduce the force of impact on the egg by having a much larger base which increased surface area, hence reducing the force of impact on the egg. While constructing our model, we thought that if we made a spread out base, there would be more surface area and the force of impact would be spread out. If we were to have a smaller base, then the point of impact would be on one spot, putting the egg at risk of cracking.
Another thing that helped reduce the force of impact were the straw shock absorbers that were attached to the outside of our egg and the base. They absorbed most of the shock that the design caught when hitting the ground. Before adding the shock absorbers to the base and around the egg, the rest of the model collapsed when it dropped. After adding the extra shock absorbers, many different components of the model caught the shock and the model stayed intact.
Third, also, we elevated the egg off of the ground to keep the egg as far away from the point of force as possible so it wouldn't crack.
Finally, we attached toothpicks horizontally to the straws that were connected to the part of the contraption suspending the eggs in the air. These toothpicks kept the vertical straws strong so that they would be able to hold up the egg easily. The straws didn't bend because of the toothpicks, which helped to absorb shock. Our model was successful in surviving all 3 falls. If we knew at the beginning of our project what we know now, we would have made our model lighter by using less tape. We should have planned out where all the tape would have gone instead of adding it as we went. Also, we started our project with an idea and worked as we went. Luckily, everything went according to plan.
We also would have put a protective device over the egg to reduce the risk of it cracking if our design hadn't landed as planned. For instance, if it had landed upside down, for example, we could have added additional shock absorbers on the top of the egg, keeping the egg safe from all angles.
Thanks for listening!
Thanks for listening!
Thanks for listening!
Thanks for listening!